Hello everyone, myself Shilpa Shrike, studying at Sri Venkateshwara College of Engineering from CSC Cybersecurity Department. Today I will be discussing about debugging in Python, a comprehensive guide. Debugging is an essential skill for any Python developer. Whether you are working on a simple script or a complex application, you are bound to encounter errors at any point. Fortunately, Python provides a range of tools to help you identify and fix these issues efficiently. This presentation will explore key debugging techniques and how to use them to troubleshoot your code effectively. Raising exceptions. Controlling error handling. Purpose of raising exceptions. Raising exceptions allows you to explicitly signal an error condition, making your code more robust and readable. It helps separate error handling logic from your map program flow, promoting better code structure. And coming to the syntax, the raise keyword is used to raise an exception. You can create custom exceptions or use built-in exception types. Getting the traceback as a string, capturing error details. Purpose of this: the traceback, which provides a detailed stock trace of the exception, is essential for understanding the cause of an error. You can capture the traceback as a string for logging or analysis. And the syntax is as shown. The traceback module allows you to access the exception traceback. So we import traceback and use try block. Assertions, implementing sanity checks. Purpose of assertions. Assertions are used to enforce assumptions about your code's state. If an assertion fails, your program immediately stops, preventing potential harmful behavior. Assertions are defined using the assert statement in the syntax, and the syntax is as shown. Define calculate underscore area of width comma height colon. Assert width is greater than 0 and height is greater than 0. Width and height must be positive values. And again we return width into height. Calculate underscore area minus 5 comma 10. This will trigger an assertion error. Logging, recording program execution. Purpose of logging. The logging module provides a structured and flexible way to create log messages. It enables you to track the flow of your program, identify errors, and debug issues efficiently. And the syntax is as shown. The logging module provides functions for configuring and generating log messages. Logging levels, categorizing log messages. These are of 5 types: debug, info, warning, error, and critical. First one, debug. Detailed information useful during development. Info, confirming that things are working as expected. Warning, potential issues that may not be critical yet. Errors, several problems that may prevent the program from running. And the last one, critical. Critical errors that indicate a major failure. Disabling logging, suppressing log messages. Purpose of this: once your debugging is complete, you often want to disable log messages to reduce noise. This is especially important in production environments where excessive logs can impact performance. Syntax: set the logging level to critical to suppress all messages except critical errors. IDL is debugger, stepping through code. Purpose of this: IDL is debugger provides a user-friendly interface for stepping through your code line by line, inspecting variables and setting breakpoints. Steps. Step 1. Start IDLE and open your Python file. Step 2. Press F5 to run the script in debug mode. Step 3. Use the debugging controls. Step over, step into, step out, and continue to navigate your code. Step 4. Inspect variables and their values in the debugger window. Breakpoints, pausing execution. Purpose of this: breakpoints allow you to pause program execution at specific lines of code. This allows you to examine the state of your variables and trace the flow of your program at critical points. Syntax: in the debugger window, click on the line number where you want to set a breakpoint, or you can use the toggle breakpoint command F9 to set and remove breakpoints. Conclusion: enhancing your debugging skills. By leveraging these debugging tools, you can gain valuable insights into your code's behavior, identify and fix issues efficiently, and build more robust and reliable applications. Remember, debugging is an iterative process, and mastering these techniques will empower you to become a more effective and confident Python developer.